Welcome to another episode of TFL Talking Trucks. As always, we have another very interesting topic to discuss today, and it has to do with steering systems on trucks and also some of the more autonomous features that are coming to trucks soon, as well as electric pickup trucks. And to learn more about this, I have an expert from next year, which is Robin Milivec. So Robin, can you please quickly introduce yourself and then tell us about the company?
Sure. Thanks, Andre. I appreciate your time today. So I'm Robin Millebeck. Like you mentioned, I'm a Senior Vice President and Board Director at Nexteer. I'm responsible for technology as well as strategy for the company. And a little bit about Nexteer. So we are a global Tier 1 automotive supplier, and we supply steering and driveline systems to OEMs all over the world. Our history dates back to the early 1900s, so more than 110 years in this industry. Today we supply to more than 60 OEMs around the world and across all vehicle segments. Our headquarters is in Auburn Hills, Michigan, which is a suburb north of Detroit. And I'm talking to you today from our Global Technical Center, which is in Saginaw, Michigan, about 100 miles north of Detroit.
Thank you for joining TFL Talking Trucks podcast. If you love pickup trucks or big full-size SUVs, if you love trailering, towing, and going off-road, this is the right place to be. Together, we can make this podcast the most popular ever.
So our largest product line is the electric power steering systems, and we're the largest supplier in North America of electric power steering systems. And since we're talking about trucks, I'm really proud to say that in the truck market in North America, 90% of those vehicles use a Nexteer rack assist electric power steering system. So we know a little bit about truck steering.
I gotcha. And this is really important because people, regular truck people and SUV people may not know where all the components are coming from and what they're doing. So I'm really glad that you're here for this episode to kind of pull back the curtain a little bit and actually show us and tell us more about it, which is really interesting. And so let's start. So first, we assumed that everybody knows what electric power steering is, but before it was electric, we're talking about the assist, right? So the system that's assisting
Correct.
you when you're turning your steering wheel and you're actually trying to drive. It used to be a hydraulic pump, right? So can you kind of explain some of the basics of that? How did it start, and why are we moving to electric assist?
Sure. So even if you go back beyond, the hydraulic assist, vehicles started out with just manual steering. So you had a very high effort required to steer vehicles, especially at low speeds when you're trying to park and that sort of thing. So then there was the advent of hydraulic steering assist, which provided a steering assist to vehicles. And then I would say about 15 years ago, there was a real conversion trend that began to electric power steering. And some of the reasons that drove that trend, it was really around fuel economy standards. So if you think about a hydraulic steering system, it's powered as an accessory off the engine. So it's always dissipating energy. You're always circulating hydraulic fluid throughout the system, whether you're driving at highway speeds and with no steering input whatsoever, or in a parking lot, you continue to take energy away from the vehicle. With an electric power steering system, you only consume energy when you need it. So driving down the highway with no steering input, there is no energy consumed. But if you're in a parking lot where you need that energy, then you consume the energy only when you need it. So fuel efficiency really drove the conversion from hydraulic to electric steering systems. But then there were some side benefits of electric steering as well. One of them is at the OEM vehicle assembly plants. So if you can imagine the assembly process of a vehicle and assembling a hydraulic steering system, you have to deal with a pump, a belt, hoses, fluid fill. So it's a rather integrated process of assembling a hydraulic steering system. But with an EPS system, electric power steering system, it's a contained system. You've got one assembly that you install. So it's a much cleaner and more efficient assembly process compared to hydraulic steering. And then you get into a lot of the performance benefits that electric power steering brings. Probably the first one is just enhanced steering feel and the ability to really customize your steering efforts. So we supply to the big three OEMs that produce trucks in North America, and they all want a certain personality in the steering system. So with electric power steering, through software and algorithms, you can really customize the type of steering feel that you have, the type of returnability in the steering system, the type of efforts. It's really limitless in terms of what we can do to customize that steering system and provide the personality that the OEMs are looking for. So that was one of the great benefits of EPS. And then now you see with the advent of a lot of autonomous driving features, there's new technology that play right into that. Things like lane keeping assist. We have a feature called Crosswind Compensation. So imagine driving down a highway, there's a crosswind blowing your vehicle to the side, and if the driver has to constantly fight that to stay straight,
right,
the steering system can recognize that and then provide the effort for the driver so the driver doesn't have to constantly fight that. That also works on a crowned road as well. And then things like auto park, trailer backup. So you're seeing a lot of features that can now be implemented once you have that base EPS system on board.
So yeah, I remember about 10 years ago when I started in the industry, there was hydraulic assist systems, like you said, right? Hydraulic assist, including trucks, in most vehicles. And then the switch was happening, like you said, about 15 years ago, maybe it started?
It started about 15 years ago, and 10 years ago really started wholesale globally, yes.
Yeah. So, and the first, what I was hearing from the industry or from the consumers is that, especially on the higher performance vehicles, maybe a sports car segment or maybe some sport or performance sedans, that people were feeling numbness, right? So the system was working, effort was that, it was helping the driver, but a lot of those people, there was a little bit of a negative stigma maybe that said, I'm not feeling what the road is doing. I used to feel it, but I no longer feel it. And now you're talking about specific tuning of the steering feel for each manufacturer. So how did that evolve? How was the steering feel or issue managed?
Right. So it is interesting. A lot of the early systems, you had that feedback from the marketplace that they felt numb. So there's been just a lot of development in terms of motor control technology, the software and algorithms development needed to get that very precise ability to control that steering feel. So there's just been a ton of progress over the last 10 years to the point we're at today that you can really get enhanced steering feel with the electric power steering system and not only customize it, between different OEMs, but there are some vehicles that have a selector switch within the same vehicle that you can select, sport or luxury mode or even more than that, and change your steering feel based on the driving you anticipate doing.
So let's take a vehicle as an example, the new F-150, right? The current one, let's say, that's on the market right now, the 2020. So your system is on that truck, right?
It is, yes.
All right, so let's kind of walk around. You kind of gave an overview of what it's capable of. And even to the extent to where you could change it with different driving modes, right? Like you said, relaxed. And so for one feature that the F-150 can offer is like autonomous parking. So,
yes.
So talk me a little bit through that.
Right. So it's having the ability to control the steering system autonomously. So you're not relying on the driver in that case to provide the input, or you're using the EPS system or the electric steering system to actually generate the force to create the steering path. So it's a little bit different than thinking about using that system to assist the driver. In this case, you're using the full benefits of that steering system to actually control the steering path of the vehicle. In this case, it's a parking maneuver, or it could be, Ford has the feature of a trailer backup where there's a knob that you can accurately control and guide the backup of a trailer. So that's also, using the steering system and the power of that system to take full control of the steering system and not just an assist feature.
Yeah. So where does that progression go? I mean, now the next generation F-150, they're talking about semi-autonomous driving, right? So the next generation of the truck on pre-mapped highways would be able to, still with the driver paying attention, would be able to kind of steer along the highway, right? I mean, so the progression keeps going, right?
It keeps evolving. So yeah, now you've got these semi-autonomous vehicles in development, and actually a lot of them coming to market now, where the driver can have hands off, and you can continue to use the steering system to control the path of the vehicle. So they have ADAS systems that do the path planning for the vehicle, and that system actually provides the command to the steering system in terms of telling the vehicle, what path to stay on, so the driver can remain hands off. But then you start to get into that. There's lots of additional technology that comes into play with that type of technology. So first thing is in terms of safety. So that system has to be fail-safe. So we've done a lot of development on redundancies within the system. So if there is an electrical failure or something goes wrong in the vehicle, that your steering remains safe. So a lot of technology brought to bear in terms of ensuring that any failures are mitigated and the steering system will continue to function as desired. And then, of course, you've got cybersecurity. So as these systems become more and more autonomous, you don't want the system to be able to be hacked and for these other commands to be given to the steering system other than what's legitimately given from the ADAS system. So a lot of technology, not only on the software side, but the electronic hardware that's in the steering system to provide that layer of safety and cybersecurity in those type of systems.
That is very interesting. So what is the next step? You mentioned a little bit about electric trucks as well, right? So, and steering by wire. So what's the next step?
Yeah, so many OEMs are looking at, if we focus on the electric truck market, they're coming out with these fully battery electric vehicles in the truck market as well. So those vehicles, naturally, the electric power steering system is a ready fit for it because it's powered by electricity, and you got a battery electric vehicle. That's a natural fit. But there's some unique things about those battery electric vehicles because they tend to be heavier on the front end because you've got a lot of battery weight. So the loads required to steer those vehicles, especially the full-size trucks and larger, tend to be very high. So we've developed a technology called high output rack assist DPS, which now can take the amount of steering loads to a higher level. So a current system that's in, say, an F-150 today can steer up to 15 kilonewtons of steering load. These new high output systems can go up to 24 kilonewtons of load. So they can steer these even heavier vehicles, the battery electric vehicle being one of them. So that's kind of where that technology is headed in terms of these battery electric vehicles. They do require even more advanced technology to steer these higher loads.
Interesting. And is steering by wire a separate kind of area of development, or is it kind of, do you see steering by wire also entering the truck market?
Yeah, so steer by wire is an interesting technology that, people have thought about this in the automotive market for a long time. And, you see in the aerospace industry, those controls are all by wire as well. But a steer-by-wire system certainly is achievable, but there were some hurdles that we had to overcome. The first one being steering feel. So getting back to your comment about numbness with the electric power steering system, imagine now that if you eliminate that mechanical connection completely, so there's no mechanical connection between your steering wheel and the steering gear in the vehicle, but you still want to feel connected to the road. You still want to feel what's happening on the road.
Yeah.
So there was a lot of development that we've done over the past 3 years or so to be able to sense what's happening at the road wheels and then be able to reproduce that at the steering wheel so the driver still feels connected to the road, so they know when they hit a gravel patch or they know when they hit ice. It's very important. So that was a hurdle that had to be overcome to get steer-by-wire in the automotive industry to be even considered. And then again, you've got the safety aspect. So with the current steering system, you've always got this mechanical backup.
Mm-hmm.
You've got that mechanical connection. So if you lose
it's basically a shaft that's going from your steering wheel down to where the axle is. Yeah.
Exactly. So you've always got that mechanical connection. So if you lose your steering assist, you still have control of the vehicle, even though the efforts might be higher. But now you go to steer by wire, you lose that shaft. So now the redundancy and the safety measures increase again. So you've got to have that redundancy and that complete fail-safe assurance that the steering system is going to be safe. So once you kind of pass those two hurdles, which we've done over the past couple of years, you start to really explore some of the benefits that this would have in the market. The first one is flexibility to the OEMs. So you said there's a steering shaft today that they have to be able to package that goes through the firewall, and there's lots of fight for that space under the dash. You've got heads-up displays coming, and that takes up a lot of space. So there's always a lot of fight between the suppliers on that real estate in the dash. With steer-by-wire, you don't have that shaft going through the firewall anymore. So it becomes very flexible in terms of how you can configure the steering system in a vehicle. And then another good thing I like to talk about is today with the mechanical connection to the steering system, you've got a fixed steering ratio. So, you turn the steering wheel a certain amount, you get a certain output at the steering wheels because you've got that fixed mechanical ratio. With steer-by-wire, you don't have that mechanical connection. So now you can start to vary the steering ratio depending on the type of driving you're doing. So if you're in a parking lot and you want the car to feel like a go-kart, you can have that very, very sensitive steering response. But now you're at highway speeds, you can change that steering ratio. So it opens up a lot of flexibility in the steering ratio, and again, having that level of customization or variability in the vehicle. And then you've got advanced safety features. So a lot of vehicles today have automatic emergency braking. Mm-hmm. So if the vehicle is traveling, there's a parked car in front of them, and if the driver doesn't apply the brakes on time, the vehicle can intervene, apply the brakes, and reduce or eliminate the impact of the obstacle. So now you can start to think about, okay, what if we added not only braking, but some steering maneuver as well that would help avoid a collision in those cases. So what steer-by-wire does is now you no longer have that mechanical connection, so you could steer the vehicle without fighting the driver. If the driver's holding on to the steering wheel, you can make an evasive steering maneuver without trying to fight what the driver's doing if the driver's not paying attention. So it enables a whole new realm of safety features that could be applied in the future.
That's very interesting. Yeah, definitely doesn't sound easy. Whatever it is, it sounds quite involved, that process. So I want to, two trains of thought right now. So you mentioned high output, right? HO system that can actually put more effort or be able to steer a bigger or heavier vehicle. Do you see that going into the heavy duty pickup truck segment as well?
It does. So those vehicles, like the heavy duty trucks, they also, like the battery vehicles, tend to have higher steering loads. That's why today they use hydraulic steering still. So with this new product, the high output steering system, now those type of vehicles can convert to electric power steering and get the benefits of the improved fuel economy, the driver assist features like lane keeping, all the advantages of the electric steering system can now be brought into that market. And if you look at the market with those heavy duty trucks, I mean, you could easily spend $70,000, $80,000 on one of those high-end pickup trucks, mm-hmm. and you're not getting the features that the light duty trucks have from a steering standpoint. So I think this is a really good technology that's going to allow OEMs to bring those features into those upper level vehicles.
So what does it take? Is it just kind of a more higher powered electric motor? So what is the high output system? Just kind of bigger capacity? Is that what it is?
Yeah, it's actually several things. So the mechanical system is bigger. So, the rack and pinion gear is bigger. The motor, the electric motor is bigger, and it's a different configuration in order to be able to supply that power efficiently. And then the power electronics, if you will, the ECUs that power that system have to be more robust and have to be able to dissipate that higher electrical throughput. So it's really a combination of the electric motor, the power electronics, and the mechanical system all had to be upgraded to carry those type of loads.
Cool. Can you talk about, so the next is the electric truck. And can you talk about any specific manufacturer you're working with now, or is that too early to tell how those systems will work in electric
Yes.
trucks?
It's too early for me to talk specifically about those, but I can tell you we are working with OEMs on their electric pickup trucks. And in general, it does require this high output EPS steering system. But it's a really exciting time. I mean, we'll see what the consumer demand is for these electric vehicles in the truck market. But certainly it seems to be pulling a lot of advanced technology into that market, which I think is going to be good for the industry as a whole.
That makes a lot of sense. And maybe steering by wire in an electric vehicle, that's also very useful because you no longer have an engine up front, right? So,
Right.
so there is
Right.
space there that a lot of manufacturers now are going to be using for storage or cargo carrying capacity. So
Exactly.
yeah,
And I
that's
would say a lot of the packaging, with a battery that tends to be, run the full length of the vehicle on the chassis, that does present some packaging issues with the steering shaft as well. And, just to kind of build upon that, if you think about autonomous vehicles, and as we move towards more autonomous vehicles in the future, there'll be a segment that, people want to drive manually, but they also might want to make their vehicle drive in autonomous mode as well. So you could envision a vehicle switching between autonomous and manual driving based on what the driver wants. And so when a driver is in autonomous mode, they would like to be able to maybe reconfigure the space that they're in. So having the steering wheel right in front of them might not be desirable when you're in autonomous mode. Mm-hmm. And what steer-by-wire does is, because you don't have that mechanical connection, you've got a lot more flexibility with what you can do with the steering wheel. So you could stow it into the dashboard. You can do lots of things with it. It opens up a lot of flexibility to, again, reconfigure that cockpit for the autonomous driver so that they can reuse that space more efficiently.
That's very cool. So for trucks, if we talk about, passenger vehicles or sedans and trucks, like an F-150, I mean, it still can tow a very heavy trailer, right? So the steering system on an F-150 truck, that's also a little bit more heavy duty than like a passenger vehicle, right?
It is. And it depends on the segment, but you're right. Generally, the larger the vehicle class, the more output you need from the steering system. So typically, full-size trucks require a technology that we call rack assist EPS, which is much higher output. But then if you go into some of the smaller compact cars, there's other electric steering technologies like a column assist, or we call pinion assist, that has lower outputs for those smaller vehicles. But it all comes down to the front end loads typically and what type of steering loads that you're encountering.
Cool. Next, I want to talk about sort of maneuverability. So you mentioned a little bit about rear steering or rear wheel steering. And obviously pickup trucks are only getting bigger year by year. The wheelbases are getting longer. They're getting heavier. So are you working on any rear steering solutions?
Yeah, it's really interesting. So if for those people that remember back to the early 2000s, GM actually released a vehicle for a few years that had a feature called Quadrasteer.
Yep.
And Quadrasteer was rear wheel steering. It was provided by Nexteer, and really just a cool technology. I had one of those vehicles. It's probably one of the most desirable features that me as a consumer that I would buy tomorrow if it was available on the market. And it took a large vehicle like a full-size truck. And, I think a lot of consumers, if you think about who uses that, whether it's, the person taking their kids to school or having to spend time in a parking lot, that could be intimidating. But when you've got rear steer, the maneuverability of that vehicle is just amazing. So you can take the turning circle of a full-size truck and really make that similar to a compact car. So you have such optimized maneuverability in parking spaces and that sort of thing. And the technology works so at low speeds, the front wheels steer in one direction, the rear wheels actually steer in the opposite, so that you can get this very tight turning radius. Mm-hmm. But then when you're on highway speeds, and this is where it gets into trailerability, the front wheels and the rear wheels can turn in the same direction. And what that does is it causes a much more stability in the trailer for kind of high-speed lane change maneuvers. And the GM application actually had a switch on the dash that you could turn four-wheel steer on or off. And it's really amazing. So if you're driving down the highway, you turn four-wheel steer off, and you do a very rapid lane change maneuver going 60 miles an hour. It's very easy to get the trailer to sway behind you. It feels very unsafe and very unstable. But then you put the four-wheel steer on, and the truck just kind of glides into the lanes because both the front and the rear of the truck are kind of on the same path because they're both steering in the same direction. And it creates a significant improvement in the stability of the trailer. So that's some of the benefits that the rear wheel steering just adds, and it's really great technology.
Is that technology coming back? What's the future of that?
So we hope so. I mean, it's a great feature. It's something that we continue to refine and keep on our shelf because we really recognize it as a good technology for the OEMs. So yeah, we're very hopeful that it comes back, and I think the OEMs have to think about, because this is a big market for them. I mean, that's their bread and butter. So nobody wants to necessarily destroy the value of that market, but this rear steering can really enhance I think the consumer appeal to the full-size truck market by offering this increased maneuverability. So yeah, we've got the technology, and we'd be more than happy to implement that as the OEMs kind of reevaluate that going forward.
Yeah, I think one obstacle with Quadrasteer was the initial cost. When it first came to market, the consumer cost was quite high. So I think that's probably on the mind of all manufacturers, right? But obviously, performance cars and many high-end vehicles currently have rear steering. So even it doesn't have to be a truck to get some of the benefits of this system. It also helps, if you're on a performance track experience, it can also help. And like Porsches and some other vehicles use rear wheel steering. So it could be a real differentiator, I think, if some manufacturer actually goes there. In my opinion, I think it could be really huge. Is there any development in the type of system where either in the front or the rear you could steer, for example, take the front axle where you could steer both tires in the opposite direction? So they're actually independent of each other. Is there any development in that area?
So we've looked at that in the past, having separate actuators on the right hand versus the left hand side of the vehicle. So the technology is there. It's usable, but I would say from the work we've done, it's not always the most cost effective solution to steering the vehicle. And then comparing the benefits that you might get from having that flexibility of left and right hand, steering independently. But the technology is certainly there, and it can be electrified, much as our current systems are. And it is something that we have looked at.
Yeah, that's really interesting because, for example, I remember recently Rivian, they did this tank turn maneuver where, because they have 4 motors on their electric pickup truck, they're able to drive each motor separately. But a lot of our audience said, well, why couldn't you steer each wheel separately? Right? I mean, if you do have that capability, and then you can turn almost basically within the space of your own vehicle, right?
Right. So yes, that technology has been looked at, and again, it's the cost effectiveness of it, and then how do you package those systems into the vehicle platforms. But it opens up a lot of interesting opportunities out there in that market.
Yeah, that's very interesting, and a lot of. So, do you also, for example, full-size SUVs? I mean, is that the same story as a pickup truck, like the new Tahoes and Suburbans, all that stuff?
Yes, that whole segment, I would say, that are still classified as light duty, the Tahoes and the Yukons, those are still utilizing electric power steering. A very similar system that would be in the light duty pickup truck.
Yeah, and a lot of these trucks are also, especially like the new Tahoe, they're getting rid of the rear axle. So they're going independent suspension in the rear, like the Ford Expedition has had for many, many, many years. So that must affect part of this story too, right? Having an axle in the back or not.
It does. I think that so it opens up a lot of packaging space if you don't have that solid axle in the back. So it gives you some additional flexibility. And for rear steer, you have to have what we call it a half shaft, but you have to have that part of the axle that is flexible so you can have that steering capability in the rear wheel. And those things that you mentioned should be some of the enablers of getting there.
What haven't we touched on, I guess?
So we've touched on, what do you hear from the people that you talk to in terms of electric vehicles? I would just be kind of curious on what the market acceptance thoughts are around electric vehicles.
Yeah, so on pickup truck market, or at least where it's going, this is a hot topic right now, right? It's kind of a race to who is going to have the first electric truck on the market. Mm-hmm. Right now, it seems to be Rivian might be first to market in June of 2021. And then there are many other companies, obviously Tesla, Nikola, which is a new company, and then, of course, Ford, General Motors, and potentially even FCA, although we don't know a lot about the FCA kind of plan for electrified trucks. So there are two schools of thought that electric trucks will first be kind of lifestyle vehicles. Mm-hmm. So the issue with, as you know, getting an electric truck to tow long distance, that's one issue. Yes. Because you're using a lot of energy like you would with an internal combustion engine also. But you're using a lot of energy, but then you need to replenish that energy, and you don't have a lot of energy density in your vehicle. You talked about the batteries, right? And they're very heavy because they're trying to hold a lot of kilowatt hours in there, a lot of energy. And so you have to recharge quickly, and then you need to actually have the infrastructure to recharge. So from a work standpoint, what we're hearing is there's a lot of resistance to that. So from the truck guys who maybe tow, even for recreational purposes, they tow long distance, maybe to a lake or to the mountains or something else. They want that flexibility to where they don't want to wait an hour and a half to charge. Yep. It's hard to pull into a charging station with a trailer, all that stuff. So that's not quite there yet, right? Mm-hmm. So those are some of the obstacles we're hearing. And then, I'm sorry, but on the kind of recreational side, let's say you're just doing a weekend trip, maybe you're going fishing, maybe you're not towing. So those are the use cases where a four-wheel drive vehicle or a pickup truck, electric, would make sense. Yeah. So yeah, but then of course this technology is going to evolve. This is an exciting time because we're kind of on this next stage of evolution of the truck, right? Right.
Yeah, we're very interested just to see what the market acceptance for those in that segment, what it's going to be. But it certainly is creating a lot of technology that we can see going into the market.
Yeah, absolutely. And so we've owned several Tesla vehicles, but so we have a small test fleet that we actually purchase. We're able to purchase vehicles with obviously, our audience watches our videos, and that allows us to have some budget, which is really great. And every Tesla passenger car, it's pretty amazing what the performance is. You're talking about, sports car type of acceleration in a big family vehicle. Mm-hmm. So these electric motors are pretty incredible. We recently did a test, Tesla Model X accelerating, and it could beat most performance cars. Mm-hmm. Coming up, we also have a Model Y Tesla against a Dodge Challenger Hellcat. So we actually put them on a drag strip, and I'm not going to spoil the results yet, but suffice it to say that these electric trucks, or cars in this case, they're super powerful, and they're also easy to use, if that makes sense. Launching a Hellcat on a drag strip is complicated. You're trying to fiddle with throttle, you have rear wheel drive, you have a lot of power going there. All-wheel drive system like the Teslas now have and these trucks, it's really easy to put, you have more traction, so it's really quite remarkable. So we don't know exactly what the market will be, right? Because all of these manufacturers are taking pre-orders.
Yeah.
So the Rivian pre-order, the Tesla pre-order, all of them are taking people's money for some pre-orders. But I think the proof will be when people are going to start using them,
mm-hmm.
and buying them.
Right. But you're right. The performance is just amazing. They're talking a lot of these, trucks, 1,000 horsepower delivered to the wheels and 0 to 60 times in 3 seconds. I mean, it's just incredible what they're talking about from a performance standpoint.
Yeah, and you're talking about what, a vehicle that weighs 6,000, 7,000. I don't know exactly what these vehicles will weigh, but they're not light vehicles.
Right, they're very heavy. Yeah.
So
one thing that reminded me, I wanted to just mention on the rear steer, if we can go back to that for a minute.
Yeah.
But you mentioned about some of these cars, like a Porsche, for example, that has rear steering. I'd say the one difference there is those systems tend to have very small angles in the rear, so maybe 2 or 3 degrees, because they're more for highway stability. Whereas the trucks, for the parking flexibility, maneuverability, they want larger angles in the rear steer. You're talking maybe 15 degrees for those type of applications. So that does require some different technology and capability for the steering system in those type of applications. And then back to the affordability, it was interesting. So the first program we did with GM when they launched Quadrasteer, I don't know if you remember these trucks, but the track on those vehicles was actually wider in the rear. And they had to put the fender flares over them with the lights. Yeah. So there was a lot of added cost that went into that system to do all of these, wider tracks and the safety elements as well. And then they offered it, kind of bundled it with some of the more premium packages. So if you wanted to get rear steering, you had to buy, the high-end Denali type of package to get it.
I remember those trucks are very desirable right now.
Yeah, right.
They're hard to find.
So I'd say over time, that has changed, and you don't need to do a wider track to get the rear steering capabilities. And I think if it was offered as kind of a base option that you pay for the feature that you want, I think consumers would find it pretty affordable. Well,
yeah. So as part of this, when we obviously publish this episode, I want your guys' input. If you're listening to this, let us know in the comments below what you think, because in my mind, the market is so competitive, right? When you're talking about, fractions of a MPG, or you're talking about 100 pounds of payload differences between these trucks, it feels like, if you do have this added feature of maneuverability, it would be a huge differentiator, right? Where you could say, your truck turns in so many feet, while mine turns way sharper. Right. So let us know. Yeah,
it does play into the tow rating of these trucks, because part of the way they classify the tow rating is the stability of the trailer under highway lane change maneuvers. So this technology does get OEMs a higher tow rating, and so that's, as you said, they're all compete every year, one kind of inches above the other, and it's very competitive. So it is an advantage for those that want to implement it first.
Yeah, I'm sure they want to beat their chest and say, my truck tows 14,000 pounds or whatever it may be. So that's very important. So I guess the question is, how much are you willing to pay? Is it $2,000 option? Is it $1,000 option? Maybe it's tied to another engine option or whatever, whatever it may be. So I'll be interested to see what the audience thinks.
Right. I would also.
As well. Well, Robin, I really want to thank you for joining me on this episode.
My pleasure, Andre. Thanks for hosting.
Yeah, because it's not often that we get to see kind of a little bit behind the curtain. We can test the truck, go off-road, go tow with it, but not often do we get to see actually what's happening within it, right? So that's really cool.
Yeah. Well, thank you very much. Appreciate your time.
All right. Thanks.